This is the First Coast Math Clinic with Lesson 12, solving application problems with equations from Unit 2, Equations and Expressions, from our Pre-algebra and Algebra curriculum. So the goal in this video is to write equations to solve application problems. The last couple videos, we worked on solving equations. In the previous video, we did some work with writing equations and expressions, given verbal statements. So today we're going to kind of put everything together and solve some application problems and set up some equations to solve those application problems. So let's get into example number 1. Sarah is 28 years younger than her father. Their ages total 60. How old is Sarah and how old is her father? So first thing is, well, let's figure out what are we answering? What question are we answering? And the question is right here. How old is Sarah and how old is her father? So that's what we want to figure out. So we want Sarah's age. And her father's age. So these are our unknown pieces of information, right? So to represent our unknown piece of information, we need to use a variable. We know that Sarah is 28 years younger than her father. So for her father, let's use X to represent her father's age. And if Sarah is 28 years younger than her father, well, Sarah can just be X and younger. So it's going to be X minus 28. Now, we know that their ages total 60. So let's think about the relationship that we could set up and set up maybe a verbal equation first before we write our mathematical equation. So if we do maybe like the father's age plus Sarah's age equals the total. Okay, so we know that father's age is X, Sarah's age is X minus 28, and the total is 60. We can substitute these values in, so we've got X plus X minus 28 equals 60 as our equation. Now let's solve this for X. X plus X gives us 2X minus 28 equals 60. Let's add 28 and 28. 2x equals 88. Divide by 2 and 2, and we get x equals 44. So the father's age is 44, and Sarah's age, we can do 44 minus 28, and that's going to give us 16. So Sarah's age is 16, and her father's age is 44. And just checking if our answer is reasonable. Well, both of those values, if we add up 44 plus 16, we're going to get that total 60 back. And that's a reasonable age. The difference is 28. So that's a reasonable answer. So the father's age is going to be 44 and Sarah's age is going to be 16. All right, let's move on to the next example. Brian opened a bank account with an initial deposit of $56. So let's underline that. So our initial deposit is $56. Each week he deposited $37 into the account. So each week he deposited $37 into the account. Write an equation to determine the number of weeks it will take him to have $500 into the account. So we want to determine the number of weeks it will take him to have $500 into the account, So what's our unknown, or what's our variable? It's going to be W, the number of weeks. So that's our unknown. And let's think of our information, right? So we start with, we've got our initial deposit. So the amount we start with, and we add our deposit each week. So how much money we deposit each week, add that up, equals our total. All right, so our initial deposit, well, we know that that is just 56, plus we know our total, we want our total to be 500. What about our deposit each week? So how do we account for the amount of money deposited each week? Well, we know he deposits $37 each week, and the weeks are represented by W. So to account for the money deposited each week, we want to take the amount of money deposited each week and multiply it by the number of weeks. So we're going to have 37 times W. So this is going to be 37W. So that's our deposit each week. So we've got our initial deposit, 56, plus 37W equals 500. Now we can solve this for W and figure out how many weeks it will take him to have $500. So let's subtract 56 and subtract 56. We get 37W equals 444. Divide by 37, 37, and we get W equals 12 weeks. All right. Next example, Brian and Nick earned a combined $250 after a day of working. Nick earned $5 less than twice Brian's earnings. How much did each person earn? So let's first figure out what do we want to find at the end of this problem. We want to figure out how much did each person earn. So we want Nick's earnings and Brian's earnings. So let's figure out what our relationship is between these two. We know that they earned a combined or a total $250. We know Nick earned $5 less than twice Brian's earnings. So Nick earned $5 less than twice Brian's earnings. So if we say Brian's earnings are just X, then Nick earned 5 less than 2 times whatever Brian earned. So we can write 2X minus 5, and that's going to be Nick's earnings. So Nick earned $5 less than twice Brian's earnings. So we'll double Brian's earnings, 2X, and then subtract 5. And our equation, Brian's earnings, so BE, plus Nick's earnings, NE, equals our total. Well, Brian's earnings are X, plus Nick's earnings, 2X minus 5, equals our total, 250. So let's combine our like terms. 3X minus 5 equals 250. Let's solve this for X. Add 5, add 5. 3X equals 255, and then divide by 3, and divide by 3, and we get X equals 85. So Brian's earnings, $85. Then Nick's earnings, let's take the 85, put it in for X. So we'll have 2 times 85 minus 5. 2 times 85 is 170, minus 5 gives us 165. So Nick's earnings is going to be $165. All right, let's do one more example. Currently, you have $60 and your sister has $135. You decide to save $5 of your weekly paycheck, whereas your sister decides to spend her whole paycheck plus $10 each week. How long will it be before you have as much money as your sister? So you want, well, first off, what do we want to know? We want to know how long will it be before you have as much money as your sister. So our unknown, our variable x, is going to be kind of some unit of time. And if we look at, like, our time is all in weeks, per week and per week. So x is going to be the number of weeks. And we want to know how long will it be before your money equals your sister's money. So let's think about what money you have, right? So your money, you have $60. So that's your initial amount. And your deposit, so your initial amount is $60, and your sister's initial amount is $135. Your change, so your money is increasing, your increase per week, or your amount saved per week, right? So you decide you're going to save $5 per week. So you're adding $5 per week, so 5 times x to represent the number of weeks, whereas your sister is spending, so it's decreasing her whole paycheck plus an additional $10. So we're going to subtract for her, and it's going to be a decrease per week. So minus, hers is decreasing by $10 per week. So we've got your initial amount, $60, plus an additional $5 per week, equals your sister's starting amount, $135, minus her change, which is going down by $10 per week. So let's solve this for x. I'm going to start by adding the $10. Adding $10, or 10x. We get 60 plus 15x equals 135. Subtract 60 and 60. 60 cancels out on the left. And we get 15x equals 75. Divide by 15 and 15. The 15s cancel out, and we get x equals 5 weeks. So it'll be 5 weeks until you and your sister have the same amount of money. All right, so these were a couple examples for video number 12, solving application problems with equations, for Unit 2, equations and expressions with a pre-algebra focus. If you like this video, leave a like, comment, and subscribe. If you want to see any additional videos, any additional topics made, just leave them in the comments. Again, if you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.